So we've done the IV flow rates, we've done the regular dosage calculations. Last week we even did some of the dosages based on weight, and we'll come back to those here at the end of this second hour if we get some time. I want to cover our last new topic, and that is dosages based on body surface area. Now, body surface area, a lot of those medications are for skin conditions like eczema, stuff like that, or burn victims is another common place where you would calculate dosages in that way. Now, the first method I'm going to show you, because I'm the math geek, is how to calculate it using a formula. They do give two different formulas. One formula if you're using standard units, and there's going to be another formula if you're using metric units. It's based off of your height and weight. So in standard units, it would be your height in inches and your weight in pounds. So the formula is your body surface area. It's still going to give us the body surface area in meters squared, even though we're using inches and pounds. So the body surface area in meters squared will equal the square root of your height times your weight divided by 3,131. Let me give you an example of that, and then we'll look at our formula if everything's given in metric. So let's say we have a patient who is 64 inches and 140 pounds. The body surface area of that patient is going to be their height of 64 times their weight of 140 over 3,131, and then square root it. Now, for most of your calculators, if you have a cell phone, those may work differently. But if you're using most of your calculators, you'll enter this all in one piece. You'd have to usually do second square root to get the square root symbol. Now mine, the square root, the numbers go inside the square root symbol. Some of yours may do that as well. Otherwise you'll have an open parentheses. Yours might look like this, square root with an open parentheses like that. You'll have to close the parentheses at the end. Let me show you what I mean. So my square root symbol here, I got 64 inches times 140 pounds divided by the 3,131. Now, many of you would have to put a closed parentheses here before you hit equals. So if your square root symbol doesn't go over the numbers like mine does, you have to close the parentheses. Hit enter, you get 1.69. Again, we're going to go to 2 decimal places. So 1.69 meters squared. I'm going to give you guys a second to make sure you guys come up with the same thing. Yes? Perfect. So the body surface area is 1.69 square meters or meters squared. Most cell phones, you have to put the numbers in first, then you hit the square root button. Let's look at if our units are metric. It's going to happen. We will make the switch to metric at some point. The United States has left it up to individual government regulatory agencies. Right now, you cannot buy a pound of gunpowder, or you can't buy a quart of alcohol. Anything regulated by the ATF is required to be bought and sold in metric units. Probably the next, I would suspect the next agency to go is going to be the FDA. You see all your food is already labeled. Your nutritional information is in grams and milligrams anyway. All your food is dual labeled fluid ounces and then milliliters. So I would assume that would be the next change. The big holdup is roads. if I went out and changed the speed limit sign from 55 mph to 88 kph, people would be getting home a lot faster tonight. Yeah. It'll take a while, but we will make the change. So anyway, if we're using metric units, our height is going to be in centimeters, and our weight, technically it's a mass, but we're going to call it weight, is going to be in kilograms. And for these metric units, the formula for body surface area, again, it's going to give us our result in meters squared. The square root of height times weight. All that changes is the number here, 3,600 instead of 3,131. So let's say we have a patient that is 160 centimeters and 48 kilograms. Their body surface area is square root of 160 times 48 over 3,600. .46 meters squared. Is that what we came up with? This is my preferred method of calculation. It is relatively, it's fairly precise. Of course, none of the methods are going to take in body shape, body density, and stuff like that. Very possible to have the same height and weight and actually have a wide variety of body surface area. But the formula seems to be the most accurate. Another method that is used is called a nomogram. A nomogram is just a chart where you connect dots and look, see where we cross. Here's a nomogram. Now let's take a peek. Now this nomogram, by the way, I should explain. It's going to be a pain today, I see. This nomogram, we have the height over here. Notice we have it either centimeters or inches. And we have the weight over here, either in pounds or kilograms. And we find the body surface area right here in this column. This column here, this little box here that's down here, is a completely separate chart. To make the nomogram work, we had to have space between these three. So they just chose to fill up that space by putting this chart in there. That's a shortcut chart for children, and I'll show you how that works in a little bit. So anyway, let's use one of our examples that we had here. We had a patient who was 64 inches and 140 pounds. So let's check that out on the nomogram. So height of 64 inches, well, 64 is right down here. I put this red line on there so I can use it to make this for the area. Normally you'd take a ruler or the edge of a piece of paper and set it across there to line it up. 140 pounds, so 140 pounds would be right here. And you can see it lines up here on the surface area. That's 1.7, that's 1.8. It looks like it's just below the 1.75. Well, we had calculated 1.69 for that patient. So 1.75 is a little bit of an overestimate. Not enough to cause any damage, but yeah, I'd say 1.75 would be what my answer would be for the nomogram. Let's look at our second one. We had a patient of 160 centimeters and 48 kilograms. So let's look at the nomogram, 160 centimeters. That's about where we're at here. Let's just gotta move down just a touch. Right there's the 160 centimeters. 48 kilograms over here. That's 42,468. So that is right there, 48. Now, just like with our syringes, we do have to go through and make sure we know what the scale is on these. So that one comes out like 1.4, yeah, 1.46 is I guess where I'd say that is, because that's 1.42, 44, 46, 48, and 1.5. That's what we had calculated. The metric ones do seem to be a little bit closer on the nomogram, and I'm not sure why. So anyway, let's do another example. Let's say we have a patient. Come on now. Let's say that we have a patient who is 57 inches and 95 pounds. So let's look at our nomogram, 57 inches and 95 pounds. Scroll up a little bit. 57 inches is right there. 95 pounds is right about there. Now, if you're doing this, even laying a piece of paper or a ruler across here, obviously you're not going to have that in exactly the right spot. So that's one of the reasons why there's errors in this. I'm getting like, well, it's almost like dead on 1.35. Maybe a little bit closer to the 1.34. Let's see what we calculate if we use the formula. Come on. We had 1.35. Let's see what we come up if we calculate this. What formula do we use? I use 57 times 95. What goes on bottom? 3131. Very good. 1.31, 1.32. Yeah. So it is a little bit of an overestimate using the nomogram. So let's take a peek at some calculations of medications based on body surface area. So let's say we have a label that gives a recommended dose of 30 milligrams per meter squared. We have a patient that is 88 pounds and 44 inches. Now, since I am the numbers geek, I shouldn't say geek, that's not very nice. I like to use the formula better than the nomogram, also because it's more precise in my mind. What number goes on bottom here? 3131. So 1.11. So just like when we had dosages based on weight, we start out with the body surface area. So it's 1.11 meters squared over 1. And now we use our recommended dosage here to make that conversion. Meters squared is going to go on bottom so they cancel out. It's 30 milligrams per meter squared. So 30 milligrams per 1 meter squared. Meter squared cancel out. That's 33.3 milligrams over 1. So just 33.3 milligrams would be the recommended dose for that patient. Any questions? Okay. Well, yep, it's not just that dimensional analysis again. PSA is in meters squared. So we have to have meters squared on bottom here to cancel out. This is 30 milligrams is equivalent to 1 meter squared. Remember, anytime we have a rate like that, it is an equivalency. We found the dosage, 33.3 milligrams of that medication for that patient. Yeah. Yep. So let's say we have a label that says 18 to 20 milligrams per meter squared per 8 hours. And this would be a titration, you're right. And it says 25 milligrams in 4 milliliters. Yeah, titration is just a way of adjusting it. No, titration means that there's two numbers here. We can use it for adjusting there, or we can use it for adjusting time. We'll see a lot of titrations done in our next part here when we do safe dosage. We have a patient. Yes. Right now, this is all the label. This here is all the label. We don't have a doctor's order on this one. So our patient, let's see. Let's say our patient is 1 point, or 1 point. How about we do 155 centimeters and 55 kilograms. So our first step is to find the body surface area. It's always height times weight, so 155 times 55. What goes on bottom for this one? 3,600, very good. Yep. 1.54 meters squared. So now that's where we start our dosage calculation. 1.54 meters squared. Put it over 1. Now up here we have to pick one of the numbers. I usually start with the maximum. So it's the 20 milligrams per meter squared. So I'm put meters squared on bottom so they cancel out. 20 milligrams equivalent to 1 meter squared. My meters squared will disappear. But now I do have the next step here, which is 25 milligrams and 4 milliliters. So milligrams go on bottom, so they cancel out. The 4 milliliters on top. Now we'll multiply out 1.54 times 20 times 4. It's going to give us 123.2. That's milliliters on top. On bottom, we just have 25. So we divide by 25. Gives us 4.93 milliliters. Now, what do we need to put on this? Per 8 hours. Because this was per 8 hours. Yes. We ignore that in the beginning, but we do have to put it on our final answer. That is per 8 hours. So that is the max dose. It's the max dose because I used the larger of those two numbers. To find the minimum dose now, we could do this whole calculation again, or we can just do a titration with that. So I've got my 4.93. I had used the 20 here. So what I used goes on bottom. What I want to change it to goes on top, the 18. So I'll take 4.93, let's multiply times 18 divided by 20, because that's the minimum dose. That gives us 4.4. 4.44. Yep. So that's telling us that we have our safe range here of 4.44 to 4.93 milliliters every 8 hours. Yeah, that's just saying that hopefully the doctor's order better be within that range. So now let's bring in the doctor's orders. We haven't talked about the doctor's orders yet. So let's see. What we mentioned last week, one of your jobs is going to be to verify a dosage before you administer to the patient. You would think that once the doctor puts it on the chart, you just give it and be safe, but there's always a chance the doctor made a mistake, decimal point didn't show up or whatever. So you are responsible, if you're administering that dosage, you are responsible to verify it and double check it. So let's say the doctor orders 2 milliliters every 8 hours. For a patient that is 70 pounds and 47 inches. You look at the label. Our label says it recommends 7 to 8 milligrams per meter squared per day. Label also says 5 milligrams in 4 milliliters. So our first step is to find body surface area in meters squared. That'll be the square root of 70 times 47 divided by 3131. Back here. 1.03 meters squared. I'm going to start with the 8 milligrams, the max dose, just to be consistent with myself. So that is per meter squared. We need meters squared on bottom to cancel them out. That's 8 milligrams per 1 meter squared. That's what we're finding now first, yes. We're going to find the whole safe range. We're trying to make sure that that doctor's order is safe to administer. Well, that's in milliliters, so we're going to have to get to milliliters. So we're going to put milligrams on bottom now to get rid of them. Go to milliliters, 5 milligrams in 4 milliliters. So now the doctor's order is in milliliters, so let's go ahead and calculate this out. So we've got 1.03 times 8 times 4 is 32.96. That is milliliters. Over on bottom we have 5. So divide by 5. Well, it's going to be 6.59. You always go to 2 decimal places, right? That's 6.59 milliliters per what? Per day. Now, the doctor said 2 milliliters. That's below that number, but the doctor said every 8 hours. So we need to titrate this for time. Remember, a time titration works just like any other. We have the 6.59. How many hours was this for? A day is 24 hours. We want to convert it to 8. So 6.59 times 8 divided by 24. That is the time. This was calculated, the 6.59 was for 24 hours or 1 day. We want to change it to 8 hours. Yep. So we get 2.20 milliliters every 8 hours. Now, we mentioned last week it's okay to go to a smaller dose more frequently. Sometimes it's not okay to go into a bigger dose less frequently. Here we're going more frequently to a smaller dose, which is okay. We don't have to worry about that. Well, that was the max dose based on the 8 milligrams. We want to now see what the minimum dose would be based on the 7. So we're going to take that 2.20. 8 is what we had used for that. We want to change it to the 7. So 2.20 times 7 divided by 8 is 1.93 milliliters every 8 hours. So the safe dose here, as we've calculated, is 1.93, 2.20 milliliters every 8 hours. Is the doctor's dosage within that range? Yeah, 2 is almost dead in the middle of it. The doctor's dosage is definitely safe. Well, once you verify it once, you don't have to verify it again. But you technically, yeah, you do have to do it. Now, what's that? Yeah, when the order initially comes in. Now, there are, depending on where you work, a lot of places do have somebody that is in charge of just dispensing medications. So that would be your whole job, is the medications, or a big portion of your job is the medications. So it's not like you're doing all the care for the patient and verifying their medications. Some places you might be. I won't promise you'll never have to do that. But yes, yeah. And I know there's a standard. I don't know what it is. I know there's a standard of how often you have to re-verify that dosage. Um, I don't know what that is. I'm gonna have you guys try one. We have a doctor who orders 3 milliliters of medication every 6 hours for a patient who is 65 inches tall and 120 pounds. Our label says 12 to 15 milligrams per meter squared every 8 hours. Now, this part may not actually appear on the label of the medication. You may have to look that up to see what the safe dose is, but you should be able to find it. And then the label also says there's 30 milligrams in 4 milliliters. I'll give you a couple minutes. Tell me, is that doctor's order in the safe range? Let's see how this came out. Well, you can find the range. You should verify that the orders, because the doctor may have ordered too little too, and you may want to double check just to make sure. So we find the body surface area, 65 over 1, or 65 times 120 over 3131. We square root that to get 1.58 meters squared. So we start with that. I'm going to use the maximum of 15 milligrams per 1 meter squared. And then we will use the 30 milligrams in 4 milliliters. Give us 1.58 times 15 times 4, 94.8 milliliters over 30. So we divide that out to get 3.16. That's milliliters per 8 hours is what was on the label. So the first thing we have to do is titrate that to 6 hours. How do we titrate the 3.16 milliliters from 8 to 6? Times 6 over 8, right? So 2.37 milliliters every 6 hours. Now, the way to double check that is to always look at it and say, okay, if we're going to a smaller time, would we expect the dosage to get bigger or smaller? Smaller. Less time, we'd have smaller dose, right? So we'd want that number to get smaller, which it did. That's the single biggest mistake I've made with titrations is going the wrong way. Be careful with that. That's the max dose. We want to find the minimum dose. Well, technically, we can already say this is unsafe. We don't have to find the minimum dose. Let's do no. Let's do the titration just to be sure. So we want to switch it to 12 from the 15. We used 15 for that one, so it goes on bottom. See what the 12 is? So 2.37 times 12 divided by 15 gives us 1.90 milliliters in 6 hours. Because we had used the 15 here, we want to change to 12. The maximum that we found, we used the 15 here. So we want to see what it would be if we used the 12. So that's what we're doing there. The titration. We're changing from the 15 to the 12. Now, so obviously the doctor's order was over the max dose. So the range is really insignificant here. The doctor's order was over. Good chance that what the doctor did was actually thinking 8 hours. But again, you can't make that change. You have to go to the doctor and have that verified, have them redo it. Because yeah, we had, it was for 8 hours, we're changing to 6. If you're going to a smaller unit at a time, it should be a smaller dose. Right? Yeah, well, the hours we used are on the bottom, the hours we want to change to goes on top. Yes. Yep, because we had used one day, we had used 24. We had used 24 and we want to change it to 8. So what we've used, what was used for this calculation goes on bottom. What we're changing it to goes on top. So the top number goes with the ending amount, the bottom number goes with that starting amount. Let's have you guys do an example. Now again, if the titration confuses you, you can always just start over with the calculation. Let's say you have a doctor that orders a flow rate of 20 drops per minute for a patient who is 66 pounds. The label says 8 to 10 milligrams per kilogram per hour with 25 milligrams in 8 milliliters and a drop factor of 12 drops per milliliter. Yeah, I brought a little bit of everything from the last 2 weeks into this one. This is a dosage based on weight because this is milligrams per kilogram. Yeah, there is no body surface area here. That would have to say millimeters squared if this were body surface area. Just using the patient's weight. First thing we have to do is convert the weight into kilograms. So we divide by 2.2. So that is 30 kilograms is where we're at. 30, yes, is in per kilogram. So that's what we're starting with is the 30 kilogram patient. So next, let's use the max again. Again, it doesn't matter whether you start with the minimum or the max. I'm just in the habit of starting with the max. So that's what I use. So I've got the 10 milligrams per 1 kilogram, per kilogram. Kilograms are gone. We're going to convert the milligrams into milliliters. 25 milligrams in 8 milliliters. So we're now in milliliters. Doctor's orders was in drops. So let's go to drops. We have a drop factor. 1 milliliter is equivalent to 12 drops. So now we are in drops. So let's see what this brings us. 30 times 10 times 8 times 12 is 28,800 drops over 1 times 1 times 25 is 25. So I divide out the 25. We get 1,152. That's drops. What's my unit of time? Per hour is what it was saying on the label. This is per minute. So we're going to have to do some work on that. Now I could do a titration if I wanted to, or I could just do a flat out conversion. A titration would be 1 minute compared to 60 minutes, which would be the hour, right? The 60 came from the 1 hour. The 1 minute came from, it was drops per minute here. So times 1 divided by 60 gives us 19.2 drops per minute. Now that is the maximum amount allowed by that dosage. The minimum would be 19.2. We would titrate. We use the 10 up here. So we want to change it to 8. So it would be 10 on bottom, 8 on top. Remember, the 10 goes with what we're starting with. The 8 goes with what we're ending with. Giving us 15.36 drops per minute. So our safe range here is coming out to be 15.36 to 19.2 drops per minute. The doctor had ordered 20. So you just want to verify with the doctor. What do you think? Having fun yet? I'm gonna have you guys try one then to end the. If we run out of time here, just a reminder, next week is our Unit 3 test. I will have it available. You can start anytime after 7:30. At 9:30, though, we do have to start lecturing on new material next week. So just so you know. Here's what I want to give you to try. The doctor's order is for 45 drops per minute for a patient who's 198 pounds. Our label says 6 to 8 milligrams per kilogram per hour and 15 milligrams in 4 milliliters with a drop factor of 15 drops per milliliter. Verify to see if that doctor's order is in the safe range of dosage. We're down to our last couple minutes. Let's go ahead and see how you're doing. Even if you're not quite done, we'll make sure you're heading in the right direction. So our first thing is to change our weight into kilograms. We get 90 kilograms. So that's where we start. I'm going to use the max again of 8 milligrams per 1 kilogram. And then we'll change our milligrams to milliliters using 15 milligrams and 4 milliliters. And then we'll change milliliters into drops. 15 drops per 1 milliliter. So we've got 90 times 8 times 4 times 15, 43,200 drops over 15. So let's divide out the 15. We get 22,880 drops. That time range is per hour. So we have to convert that from hour to minutes. So 1 minute compared to 60 minutes would be for the hour. Or you could just divide it by 60, giving you 48 drops per minute. That's our maximum. Well, 45 is below that. Let's make sure it's not below our minimum. So we're going to take 48 times, what was it, 68? So times 6 over 8. 48 times 6 over 8 is 36. That'll be drops per minute as well. So our safe range is 36 to 48 drops per minute. And the doctor's orders is safely in that range. So pages that we had not assigned yet, I believe, page 188 through 190, 1 through 21, the odds, and page 196 through 197, that's the body surface area stuff, 1 through 19, the odds. Next week, as I said, is unit 13 or unit 3 test. It'll be available anytime to start, anytime after 7:30 each location. Anybody have any questions? I will still be around until about 11 o'clock. The network should stay up, so I'll be here with the network live for anybody who has questions. Yes.